Transmission Control Protocol. The Transmission Control Protocol, TCP, is one of the core protocols of the Internet Protocol Suite. TCP is one of the two original components of the suite, complementing the Internet Protocol, or IP, and therefore the entire suite is commonly referred to as TCP/IP. TCP provides reliable, ordered delivery of a stream of octets from a program on one computer to another program on another computer. TCP is the protocol used by major Internet applications such as World Wide Web, email, remote administration, and file transfer. Other applications which do not require reliable data stream service may use the User Datagram Protocol, or UDP, which provides a datagram service that emphasizes reduced latency over reliability. In May 1974, the Institute of Electrical and Electronic Engineers, IEEE, published a paper entitled A Protocol for Packet Network Intercommunication. The paper authors, Vince Cerf and Bob Kahn, described an internetworking protocol for sharing resources using packet switching among the nodes. The protocol corresponds to the transport layer of TCP/IP suite. TCP provides a communication service at an intermediate level between an application program and the Internet Protocol. That is, when an application program desires to send a large chunk of data across the Internet using IP, instead of breaking the data into IP-sized pieces and issuing a series of IP requests, the software can issue a single request to TCP/IP and let TCP handle the IP details. IP works by exchanging pieces of information called packets. A packet is a sequence of octets and consists of a header followed by a body. The header describes the packet's destination and, optionally, the routes to use for forwarding until it arrives at its destination. The body contains the data IP is transmitting. Due to network congestion, traffic load balancing, or other unpredictable network behavior, IP packets can be lost, duplicated, or delivered out of order. TCP detects these problems, requests retransmission of lost data, rearranges out-of-order data, and even helps minimize network congestion to reduce the occurrence of the other problems. Once the TCP receiver has reassembled the sequence of octets originally transmitted, it passes them to the application program. Thus, TCP abstracts the application's communication from the underlying networking details. TCP is utilized extensively by many of Internet's most popular applications, including the World Wide Web, email, file transfer protocol, secure shell, peer-to-peer file sharing, and some streaming media applications. TCP is optimized for accurate delivery rather than timely delivery, and therefore TCP sometimes incurs relatively long delays, running over while waiting for out-of-order message or retransmissions of lost messages. It is not particularly suitable for real-time applications such as voice over IP or internet radio or internet TV. For such applications, protocols like the Real-Time Transport Protocol (RTP) running over the User Datagram Protocol or UDP are usually recommended instead. TCP is a reliable stream delivery service that guarantees that all bytes received will be identical, which bytes sent and in the correct order. Since packet transfer is not available, the technique known as positive acknowledgement with retransmission is used to guarantee reliability of packets transferred. The fundamental technique requires the receiver to respond with an acknowledgement message as it receives the data. The sender keeps the record of each packet it sends. The sender also keeps a timer from when the packet was sent and retransmits the packet if the timer expires before the message has been acknowledged. The timer is needed in case a packet gets lost or corrupted. TCP consists of a set of rules for the protocol that are used with the Internet Protocol, and for the IP, the send data in a form of message units between computers over the Internet. While IP handles actual delivery of the data, TCP keeps track of the individual units of data transmission, called segments, that the message is divided into for efficient routing through the network. For example, when an HTML file sent from a web server, the TCP software layer of that server divides the sequence of octets of the file into segments and forwards them individually to the IP software layer or Internet layer. The Internet layer encapsulates each TCP segment into an IP packet by adding a header that includes the destination IP address. Even though every packet has the same destination, they can be routed on different paths through the network. When the client program on the destination computer receives them, the TCP layer reassembles the individual segments and ensures they are correctly ordered and error-free as it streams them to an application.